Hello, today we're looking at the power rule and how to apply that to your derivatives and make your life a whole lot easier in calculus. So when we're looking at the power rule, we're talking about taking the derivative of the variable x with a coefficient to an n power, and all you do is multiply that coefficient a by n, the exponent, and then subtract 1 from that exponent. Now I know with all those letters going around, it seems a little bit complicated at first, but I promise with a couple examples, you'll be able to use this formula in your own equations. So we're going to start with a very simplified form. We're going to use 3x raised to the second power, and we want to take the derivative of that function. In order to do this, we're going to use our rule, and the first part of that is identifying which part is a and which part is n. And so our exponent here is 2, and our coefficient is 3. Knowing that, we're now going to go to the next step of multiplying the coefficient 3 by the exponent 2, and then we're going to have our variable x, and then from that exponent of 1, we're going to subtract 1. That's going to simplify to 6x raised to the first power, which we are going to erase that because that means it's just a variable x. And so in that example, it's a little bit simple in the form, but it drives home that point of how to use the power rule. Next, we're going to look at something a little bit more complicated in appearance, but you're really going to break it all down to the same exact example every time. And that's what's so great about the power rule is no matter how complicated a polynomial gets, you can use it over and over again. So this time we're going to use the polynomial. We're going to take a derivative, and we're going to have 5x to the fourth minus 2x cubed plus 7. And so if you've been using an older method of calculating this and taking the derivative, you probably see that those exponents, the cube and raised to the fourth, and just picture a headache in your head. But with the power rule, it's going to simplify very quickly. And what we're going to do is we're going to separate it, again, identifying our coefficients as well as the exponents. And if we notice that in this example, we actually have a constant term. And if you remember your definitions of a derivative is really looking at the rate of change in a function. And because a constant term by definition cannot have change, it is constant, we're going to be able to drop that part from the polynomial. So we're not even going to worry about that when we take our derivative. We're going to go down this line, and we're going to do the same exact thing that we did before. We're going to add that exponent, 4, multiplied by 5, our variable, and then we're going to subtract 1. And we're going to use that coefficient, minus 2, we're multiplying here, and we're going to subtract 1 from the top. And again, we got rid of that constant term, so we're not going to worry about it. We're going to go ahead and simplify everything. We have 20x cubed, 3 multiplied by minus 2, it's going to be minus 6 for a variable, and then what's left. And so as you can see, utilizing the power rule is a very good way to take what seem as complicated polynomials and quickly take those derivatives. If you have any questions, feel free to leave a comment down below, and you want to see other examples, you can always email me at jj@earthquakepublishing.com. If you enjoy this type of material, make sure to drop a like and a follow. I'll see you on the next lesson.